So this is another way to graph lines. I have two more ways to show you how to graph lines. That's really what's left to learn. And then we'll be ready for our next quiz, probably already a week from today. So the second half quiz is less intensive, I think, just because a lot of the learning has already happened. So that was part one of like this chapter, if you will. And then part two has intercepts, a lot of point slope. And then do you guys remember that how we spent a couple days like write the equation of the line that passes through the point 5, 6, and has a slope of 2? We're going to have a lot of that too. But we've already kind of gone down that road. So that part of it is kind of already not quite done, but done-ish. So there's two new topics. One of them comes today, and this one should be an absolute walk in the park. So today, what's today? 12, geez Louise, 12/6. So we're going to be studying today x-intercepts and y-intercepts. So let me just give you a big picture. I'm not going to do any math really in this first example. I just want to show you big picture what we're doing today, so you can get your head around kind of the what's going on side of things. Then the math is actually stupid easy. Like I have 40 questions in today's assignment. I wouldn't be surprised if you can finish all 40 in seriously like 20 minutes. Like they go really, really fast. So some of them you might want a little bit of paper and pencil for, but the fact of the matter is, I think the vast majority of today's assignment is just mental math and just not being a ding dong. So I'll show you what's up. Anyways, the goal for today is to graph lines using just 2 points. And if you think about it, so really listen carefully because this will make this all hopefully sort of click as to why we're doing this. If I said to Gage, I need you to graph a line, and I told him where the graph crossed through the x-axis. Like if I said, okay, the graph crosses through the x-axis at -5, he could put a point there, couldn't he? And if I said, hey, Gage, by the way, it also crosses through the y-axis at -3, he could put a point there. And by definition, he now has enough information to graph a line. So if we were able, he and I together, to figure out where does the graph cross the x-axis and where does the graph cross the y-axis, then based on that information, he could very simply just grab a ruler and make a line through the 2 points and say, well, that was a walk in the park. So that's the method we're going to be using today. Is we're going to use a little bit of simple, very, very simple math to just figure out those two questions. Where does the graph cross the x-axis and where does the graph cross the y-axis? That's it. Simple, right? So before we begin, let's talk about, and this part of this conversation, you teach this every year, and this part, sometimes it takes a few minutes to get the right answer to this question, and sometimes it goes quickly. So let's see how this goes. If I spoke specifically about this purple point, and this, again, this one takes a while. What could you tell me about the purple point? Okay, so I already kind of told you that, right? It's on, these are all good things. Let's forget the -5 thing and just pretend we don't know what it is. Like we know X is negative, right? And we know it's purple. Great. We know it's on the x-axis. Now we're getting somewhere. Can you tell me something else that we know about the purple point? Which is kind of redundant, right? Like if it's on the x-axis, it's where the line crosses through the x-axis. Can you give me something a little more specific about the point? Something that you know has to be true. Yeah, not the line, just the purple point. But you're right, it does have a negative slope in this case. If someone put a gun to my head and said, I need you to give me the coordinates of the purple point, I couldn't do it. I'd say you're going to have to go ahead and shoot me because I can't tell you, like based on the information that's on the board, I cannot give you both coordinates of the point. You agree? But I could give you one of them. Which one? Which one of them has to be 0? Which, if I said to you, here's the purple point, this is the part that will either make this make sense or not. Here it goes. If I said, I need you to give me the coordinates of that purple point, you know one of them. Which one? You know the y is 0. You can't get away from that. And I don't really want to move on until you can like nod your head in agreement and say, I agree. I don't know what the X is. I'm going to put a question mark by the X because I don't know. That could be negative 6.21 repeating. It could be negative 1.6. It could be negative 34. I don't know anything about where it's really at. Yeah, I know it's negative, but whoop-de-doo. But I do know this, that because the point is on the X-axis, if I said to you, I need you to go to that purple point, the one thing that is unequivocally, like unarguably true, is that the y coordinate of this point is 0. You agree?
Yeah.
Okay. So here's what this means. Let's look at some other x-intercepts. And I'm just making these up. But if I put one here, could I say the same thing? Is the y 0? What about here? What about here? So can we all unanimously agree that if a point is on the x-axis, this is the part you really want to write down. If I am a point and I am on the x-axis, what is true about me? Say it again. The y coordinate is 0. I really want to know that you understand that. And you can already see where it could get confusing. It's just like horizontal and vertical lines. Horizontal lines look like the x-axis, but they use y. What? Vertical lines look like the y-axis, but they use x. And so what we learned from that little sentence, that little thing in purple, is that we got to train our brains to think backwards. If I'm a point and I'm on the x-axis, it's my y coordinate that equals 0. Now let me switch colors to green. Let's talk about this point. Again, I would use the same sort of analogy or way of thinking. If someone pointed to this point, put a gun to my head and said, give me the coordinates of this point, I would say, again, sorry, you're going to have to shoot me. I don't know what the coordinates are, but I do know one of them. The X literally has to be 0. If I said to you, hey, I need you to travel to that green point, unequivocally, you would go right 0 or left 0 and then down or up some amount, in this case down, right? So again, using a question mark, I can put a question mark in the y because I don't know what the y is, but I do know for sure that the x coordinate of that point is 0. So we can add to this little statement down here, this little purple writing that I did, we can make ourselves an awesome little cheat box. This is going to be our go-to like resource box. We can now definitively say, and by the way, I hope you agree, like I could do this all day. Do we agree that for that other green point, the x is 0? X is 0, 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 X is 0. We could do that all day. So we can add to our little sentence or our little writing down here. We can say, so let me get this straight. If I'm on the y-axis, what is true about me? My x has to equal 0. You might think to yourself, like, well, that's really not very exciting. Like, I kind of get it, but what's the point? The point is it enables us to graph lines really, really fast. It's sometimes not the best way to make a really good graph, but it's often a really good way to make a pretty good graph. So let me show you how we put this into practice. And by the way, if I were you taking notes, I would put a box around this and maybe draw that box again, and then maybe use like a colored pen and highlight that box, because that box is going to be the one that you flip back to when you're preparing your page of notes like a week from today, that you're going to say, I better put that in my notes. We're going to need that. So let's look at how we can put this into practice. So here is a graph. And I'm going to sketch a little x-axis action there and a little y-axis action right there. And I'm going to give you an equation. And you're going to help me graph it. So if I gave you like 3x minus 4y equals 12. At this point in your learning, prior to today's lesson, if I said to you, graph that line, I hope if things have gone well for you, that you would get y by itself, right? You might add the 4y across and move the 12, or maybe you would just subtract the 3x and divide by -4. It doesn't matter. If you can get y by itself, you can graph the line. But starting today, there's a new option available to us. It's not always the best, but All of today's problems are what you're going to do. So remember, first thing I want to do is I want to find the x-intercept. And by definition, if I'm the x-intercept, then I am the point that is on the x-axis. What is true about me if I'm on the x-axis? Good job crisscrossing there. Good job. If I'm the x, then my y has to equal 0, correct? So all I do is I simply take, and right here where this red arrow is pointing, is I magically place a 0 right there. And when you place a 0 into an algebra problem, everything it's connected to goes bye-bye. Poof, right? You agree? If I change y literally into 0, which I can do, this equation will now just say 3x equals 12. Divide both sides by 3. What's x? 4. So I can go over here to the x-axis, 1, 2, 3, 4 to the right, put a dot. And when I'm not talking to you and you're doing this by yourself, that's going to take you about 3 seconds. 5 if you're slow. 7 if you're super slow. Got it? Now, let's go find the other point. Let me switch colors. Let's find the y-intercept. What's true at the y-intercept? The x equals 0. So to find the y, you kill the x. To find the x, you kill the y. Go figure. So if I take up here where this green arrow's at, and I place a 0 in place of x, everything it's connected to vanishes, right? What would the equation now say? Negative 4y equals 12. Divide both sides by negative 4. What's y? So I go down to negative 3, put a dot, presto, you've got, boop, a line. Done. Pretty easy. Let's go again. Are you holy crapping the rapid nature of my mouse clicks? Yeah, sorry. Let's do this one. Negative x plus 6y equals 3. Again, standard practice prior to today would have been you would have added x to the other side and then divided everything by 6. That's not bad. It's just not what we're doing today. So today, and I'm going to go a little bit faster this time, and I'm going to show a little bit less work this time. I want to find the x-intercept first. Who dies if I'm finding x? What would this equation say? Negative x equals 3, so we divide by negative 1, x equals negative 3. I really wish that this dot worked over here. I apologize that it's, let me see if I can fudge that a little bit. There, I kind of cheated that. So we're going to go across left to x at negative 3, put a dot. Let's find the y-intercept. Who dies when I'm finding the y? The negative x goes bye-bye, and the equation says 6y equals 3. Divide both sides by 6 and don't say 2. What do you get? You get y equals 1/2. So I simply go up to 1/2, which is about halfway to 1, and you've got 2 points. Make a line. Done. You okay with that? It is easy, and I hope that if the last 7 minutes went well, that's exactly what you should be thinking right now. Is like, what's he holding out on? Like, where does this get hard? It never does. You simply literally murder one of the variables and then solve what's left, make a dot, murder the other variable, solve what's left, make a dot, connect the dots. Again, sometimes it's the best method. Sometimes you're like, man, this isn't appropriate, but it will be appropriate on all of today's problems. So let me show you what your Delta math is going to look like, just so you're prepared when you get there. I don't want it to be like a mystery to you. Today's assignment is going to be a mixture of 2 skills, and both, I imagine, going to be pretty straightforward. So one of them has nothing to do with actually graphing. And so here's an example of a problem. And all it's going to ask us to do is find the intercepts, not use them for any purpose, just practice finding them. So half of your problems will look like this. And so if I want to find the x, who goes away? And do this in your head right now. It's okay. Do this in your head. If the y goes away, what would the equation say? 3x equals 39. Divide by 3. What's x? So I simply go down here in the box for the x-intercept and I type 13. Now I reset my brain. If I want to find the y, who dies? X does. What would the equation say? Negative 8y equals 39. Divide by negative 8. What does y come out to be? Can 39 divide by 8? No. So I know it's going to be a fraction. Can 39 and 8 reduce? No. 39 and 8 have no common factors. So my y-intercept is simply negative 39 eighths. And I missed one earlier because I forgot to reduce a fraction. When I was clicking through these and just monkeying around, I forgot to reduce. It will mark you wrong. Like I had 22 over 6 and forgot to put 11 over 3. The other type of problem that you're going to see is graphing using the intercepts. I know a lot of you have already started. I hope you haven't stopped listening. Problems like this, you never have to explicitly state what the intercepts are. It's just a graph. So on this one, easy. If I want to find x, who do I kill? Find x, kill y. What would the equation say? 5x equals 25. Divide both sides by 5. What's x? So I simply take this red dot and I drag it and place it really close to the 5. Now, for the y-intercept, who dies? What would the equation say? Negative 5y equals 25. Divide both sides by negative 5. What's y? It's not 5, it's negative 5. So I grab the blue dot and I drag it down to negative 5. And just like that, I've got a line, full send, done. Okay, let's go again. Look at this one. Quickly, what's the x-intercept? In your head, it's 5. If the y goes away, you go 20 divided by 4 is 5. So my x is already in the right spot. Y-intercept, what is the y-intercept? Get rid of the x. What is the y-intercept? Divide by 7. Can 20 divide by 7? Then the answer is 27ths. But I'm not out of the woods yet, because if I'm not listening right now, I'm going to be the kid that later goes, how do you graph 27ths? Make sure you're listening. 27ths can be tricky, but not if you think of it as a mixed number. How many times does 7 go into 20? 2 times. And what is 2 times 7? And what do you have to add to 14 to make 20? So the answer is 2 and 6/7. And so you might say, well, how am I supposed to graph 2 and 6/7? Well, you go to 2, and then you estimate that 6/7 is pretty close to 3, but not quite to 3. And I've learned from this that the Delta Math program is pretty forgiving. Like if I go above the 3 like this, that's clearly not a good answer. It should mark this one wrong, right? Because I didn't go to the right place. So what I did is I dragged my dot a little bit too high. You see how it wants to be a little below the 3. So it's not a very exact science with some of these fractions, but you still have to not be a dunce about it. Like if it's 3/4, just stay proportionally where you think 3/4 is. And if you're really, really close, it'll count it right. You guys got it? So this is your other method for graphing lines. We should not have to practice this more than one day today. Let's get this done, and then let's get out of here. And tomorrow we'll start talking about point slope again. Sound good? Let me know if I can help you.